Okay, so today we're going to look at the OSI model in detail, and we'll go through the layers and see if we can't explain how the abstraction all works. So let's go ahead and get started. Layer 7 in the OSI model is the application layer. That's where a network protocol interacts with a network-aware application. That can be something like Snapchat, or that can be something like even Microsoft Word has network awareness. You can upload documents to OneDrive or whatever you use for a cloud. So basically, at layer 7, that's where the network protocol interacts with the network-aware application, the program. Layer 6 is a presentation layer. That's where the data is prepared for transmission between the application and the session layers. Layer 5, or the session layer, is the OSI model layer where a data transmission channel known as a session is established between communicating devices. When you have a server and a client, you need to have a session, and basically that session can expire. And we'll talk about that a little bit later. But yeah, if you've ever had your session expire, you suddenly lost your connection with the server, and now you have to re-authenticate, because that is what establishes the session. Don't forget, complete the embedded assignments. Layer 4, transport layer. That's the data where the upper level layers, they're divided into smaller sized blocks of data for faster transmission. So basically, we're breaking the data down so that we can send it out. Transmission Control Protocol, TCP, is the set of rules that controls that. It's a network protocol used to establish a guaranteed connection-oriented communication channel. So we're establishing the channel between the server and the client. And then UDP is another protocol similar to TCP. There are some differences. The main one being that UDP provides a non-guaranteed connectionless data transport. So what that means is UDP does not check for data completeness or data correctness. It doesn't do any error handling at all. It just sends the data in a splurt, and then once the data is sent, it doesn't worry about what happens later. Whereas TCP goes back and does error handling, data checking to make sure that the information was sent correctly. So TCP takes a little bit longer, but it's also more reliable. And that is the main thing you want to remember as far as the difference between these two. A segment is a TCP flag. It's a PDU, basically a piece of data. It's a data unit created by TCP. It includes the TCP header. That's the connection state information, and that is what the TCP flag is. A datagram is the data unit created by UDP. So this is associated with UDP, where a segment is associated with TCP. And so based on which protocol you're using, this is the type of data packet that will be created, or data unit. Also, don't forget, it's explained a little more thoroughly in this activity. Then layer 3, the OSI model, is where data receives logical address information. So basically what you need to do is you need to label the data packet with information so that it can be reassembled, and so that it can get where it needs to go. You need to have the IP address, for example, for the receiving network, so it'll go where it needs to go, and then that network can check and make sure that it's received the information that it's supposed to receive, and that message belongs to it. IP, Internet Protocol, is a network protocol used to address data. This is the protocol that determines how this information is added to the packet. And then a packet is a data unit created by the IP protocol, and it includes IP header, and that is the logical address information, the information where the sending, receiving servers' IP addresses and things like that are formed, so that the packet gets where it's supposed to go. A router is a layer 3 networking device connecting two networks. And then the routing protocol is a network protocol used by a router to determine the best way to send the data. Because, as you know, with packet routed data or packet transferred data, there is no one line back in the old days when we had telephone systems, there was just one line. You had a person called, a person answered. There was one circuit. It was specific to that conversation. And when they hung up, they broke the circuit. But until they hung up, that circuit was open. With packet transferred data, essentially what happens is the data can travel from point A to point B across many different routes. There's no law that says two packets from the same message have to take the same route or go through the same servers. What matters is that when you reach the destination, then your message is put back together using the appropriate protocols. And because it has the appropriate header information, the receiving station knows, this is how I'm supposed to put this message back together. So the routing protocol is what controls that to make sure that the easiest or the best path is being chosen to get the message where it needs to go. Also, don't forget, you have another participation activity. Layer 2 is the data link layer. That's where the data is transmitted to the recipient node. A frame is another data unit. So basically you're taking frames, putting them in packets, and then those are different data units. So you're sub-encapsulating. You have units inside of units. In layer 2, we're building frames, and that is a unit created by the layer 2, contains the data transmission parameters and the physical address. Logical link control, LLC, is a layer 2 sublayer providing data flow control, error detection, and error correction if it's TCP/IP. Remember, there's no UDP doesn't do that. Media access control, the MAC address, it's a physical address that is assigned to a network-aware device or component by the manufacturer. If you look at the MAC address from the same manufacturer on different devices, the first few characters of the MAC address will be the same. Those characters are assigned to the manufacturer, and then the last characters in the MAC address are individual. So it's like an IP address. You have the network part of an IP address, and then you have the host part. The network part all has to be the same, and then the host part has to be unique. Well, with MAC addresses, the first part of the address is manufacturer specific, and the last part is host or device specific. A switch is a layer 2 networking device. It acts as a central node between two other nodes. So if you have two computers, you can network them together using a switch. Layer 1, that's the physical layer where the payload is transmitted across the network. That's the actual copper or the actual radio waves if it's a Wi-Fi network. Radio wave is artificially generated energy. It's electromagnetic energy. It radiates electrical current into an open space. Binary number, we'll talk a little bit about binary. I think it's in chapter 4, but it's basically a base 2 number system. Computers use it because computers only have two states, on and off. Any machine can be on or any machine can be off, but they can't be halfway on and halfway off. So computers use binary as a basis for their control and their programming and everything. A bit, that's a binary digit. It can be a 1 or it can be a 0, and that is the extent of it. Encapsulation activity, you need to make sure you do that. Also, you need to make sure you do the challenge activity. Once you have done those things, then you have completed this section. You can move on to the next section. All right. So that is the OSI model. Remember, it's 7 layers, and you need to know what each of those layers do. That is going to be a large part of the A+ test, so make sure that you're very familiar with those layers. Also, by way of comparison, you need to know that the DoD model that we're going to look at next, you need to know what layers from OSI conform to what layers from DoD or correspond with what layers of DoD. So if you have any questions, let me know. You can send me a message through the Canvas inbox, or you can ask me in class. I'll do my best to help. Have a good day.